Hey! Good evening, everyone. I'm also going to do my talk in English because my Hebrew is terrible. And I wouldn't want to embarrass myself in front of you all. First of all, thank you so much for coming to see, well, me and everyone who's speaking. I really appreciate you coming to take the time out of your evening to do so. My name, as you heard, is Mark Mandel. I'm a developer advocate for Google Cloud Platform, but I also work quite closely with the Firebase team. They actually quite literally sit around the corner from me. I am here to talk to you about creating interactive multiplayer experiences with Firebase, which sounds very buzzwordy. Basically, we're going to look at writing like web games with JavaScript, and it's kind of fun, and building it with Firebase. That we're all kind of on the same page as well. I'll give a very quick overview of Firebase, and then we'll start digging into some particular features that I think are kind of interesting. Some of these features that I'm talking about are probably basic stuff that you already know about. Some of them are new and came out at I/O recently, earlier in the year. And so hopefully you all learned something new and exciting and fun to play with. Firebase has a cool new logo, and it does that. Yay! That's it. I can go home now. See ya. Cool. So what is Firebase, if you're not familiar with it? In a nutshell, the way I like to explain Firebase is a backend as a service. So you sit down, you write client-side code, be that JavaScript, as we're about to see here, maybe Objective-C or Java for, say, Android or iOS development. But really all you're doing is you're writing client-side code that connects to a backend that you don't have to manage or control or worry about scale or any of those really annoying ops types problems. And the way it does that is it gives you a whole bunch of features out of the box that you can interact with. Now, we're going to look at some of these. Some of them apply to the JavaScript stuff. Some of them don't at this stage. There's a bit of disparity between what's available on the web and what's available on mobile. So I'll be focusing on the mobile ones today. But it gives you a whole bunch of services. When it first started, it was really only a couple of those sort of services. And we'll look at some of those, say like RealTime, the RealTime Database and the Authentication API. But since Google really has invested in Firebase, so if anyone's like, Google could kill Firebase at any point in time, please don't think that. We just announced like so many really cool things within Firebase, and there's so much new stuff coming up in it as well. It's a really, really fun and exciting project. OK, so now I've given you all the marketing spin. I'm sure you're all sick of that, and that's great. Let's actually build something, because that's the fun stuff, right? We like developing things. So when I sat down to do this talk, I was like, OK, let's take an existing type game, and let's make it multiplayer, because that sounds like that's going to be cool and fun. So what's a really basic and simple game? Well, I was like, OK, the most basic, simple game around, rock, paper, scissors, right? I assume we've all played rock, paper, scissors. So very simple game. Rock beats scissors, scissors cuts paper, paper covers rock, which never made any sense to me, but sure, why not? And it's a pretty simple game. And we're like, all right, cool, let's kind of make that multiplayer over the internet using like a web-based browser type game fun thing. But then I was like, that's boring. We can do something a bit more interesting than that, can't we? So as you know, because I mentioned it before, I'm actually a developer advocate for Google Cloud Platform. So one of the things we have at Google Cloud Platform is a thing called Cloud Vision API. And what that is it's a pre-baked machine learning doohickey that you can send images to. And one of the things it can do is it says, oh, is there a face in that image? And if it is, I can tell you what emotion that face is actually going to be showing you. So we can tell you whether you're happy, or you're surprised, or you're angry, and several other emotions as well. So I'm not going to dig too deeply into that. But when I was looking at it, I was thinking, wait, we can take rock, paper, scissors, and we can make happy, angry, surprised. That seems like way more fun. So if we make a game that looks at the emotions you have on your face, and we say, let's match those up between two players and make people make really funny faces, then we can make a really fun game. So what are the rules of happy, angry, surprised? They're pretty straightforward. So happy beats angry. surprised beats happy, and angry beats surprised. I mean, I think that's pretty logical, right? That makes sense. Yeah? Cool. So those are the rules of the game. That's pretty much it. So I built a little web app. It's probably some of the most front-end code I've written in a while. But here's the web app I wrote. It is like boring, plain JavaScript, right? There is no frameworks. There's nothing like that. It's really boring and plain. I'm using Material Design Lite for just the UI because I'm a terrible designer. That's why I married one. I've got very simple things. We've got some authentication up in the top left. We've got a group chat. We've got some matchmaking so people can find each other and play games. And then we've also got 2 images there where I've actually played a game, unfortunately with myself because I have no friends. But hopefully we can change that this evening. Where one player, me, has happy, and the other player, also me, is angry. And the happy player has won because happy beats angry. And this is the app that we're going to sort of talk about today and how it's all built with Firebase. Does that sound pretty cool? Excellent. So first things first, how do we authenticate with Firebase? Right? How do we get the keys to the kingdom, so to speak? How do we go, OK, Firebase, let me in and access these services that you have? It's pretty straightforward. I go to Firebase, and I go to the documentation, and I go to the web section, and I say, give me my config, and then I paste it into my page. And then I say, Firebase initialize app, and I'm good. That's really it. That's all I really need to do. It's a bit of copy-paste. And from now, I have access to all the services, all the services that Firebase gives me out of the box. I don't have to do anything special here now. All the authentication keys are available to me, and that's pretty much all I got to do. So that's cool. Again, and I haven't had to set up really anything other than create a Firebase project. I'm not spinning up servers. I'm not saying how big I want them, anything like that. It's just all available and ready for me to go. So I have access to Firebase. Excellent. First step in this application, right? I have a game. It's a multiplayer game. So the first thing I really care about is who is this player, right? I need them to authenticate in some way, shape, or form. Otherwise, I have no idea who they are. And having some sort of identity in a game is kind of important, because if I don't have identity, I don't know who to hate, and then what's the point of gaming, right? As I said before, up in the top left-hand corner, we have a login button. And I want to be able to log in this particular game. I would like to have a username and password that people can use if they want to do their manual username and passwords. But I also want OAuth with Google. That would be nice. Those are the 2 things I want in this particular app. Now, the nice thing is Firebase comes out of the box with authentication capabilities. It does authentication for Twitter, GitHub, Facebook, Google. I'm probably missing one, but that's fine. Username and password. It'll do anonymous authentication as well. And on top of that, it does all your session management for you as well. You don't have to worry about a backend and doing session tokens or anything like that. It provides those for you in a secure manner. And you don't have to worry about those sort of authentication, backwards and forwards procedure calls or anything like that to say, where's my session token, any of that sort of stuff. Firebase takes care of that, which is really, really cool and super, super powerful. In Firebase 2.0, if you're familiar with it from before, a new feature is actually it also does federated login out of the box. So if one day I want to log into an app using Google, and then the next day I want to log into an app using Facebook, I can tell Firebase, or the application itself, hey, Firebase, link these 2 accounts so that I can log in with either, and it's going to be oh, sweet. Those are the 2 same things. Fantastic. So what does that code look like? This is the code that's in my application right now. I'm telling it if I want to create a user and create a user with an email and password. It's just create user with email and password, passing in those values that I got from some DOM elements. It's worth noting there, you can see where I've got a user update profile. That user isn't just limited to a username and password. I can add extra values. So in this particular case, I'm adding a display name, which I'll probably end up using in my chat application later on. If I want to log them in, once I have an account with a username and password, sign in with username and password, or email and password, sorry. That's it. I'm logged in. Cool. All right, no session management, no backend services, I'm good to go. If I want to sign in with Google, and this is true for all the other sort of OAuth-y type things as well, we have something called an auth provider. Here it has a Google Auth provider, and what it basically is an abstraction that sits over your native, like, hey, this is how I log in with Google. And it creates a Firebase credential that you're able to pass in, and then I can sign in with that credential. Again, I don't have to do anything really more than this, right? I drop the standard Google button on, boom, I'm good to go. It's worth noting, just as a little cute best practice that comes with Firebase, Firebase has this nice thing called OnOff State changed. I think in Firebase version 2, which is the previous one, it was like OnOff. Same thing. But basically, it's a nice listener that says, hey, if your authentication state changes, so if you log in or log out, I will fire. This means if you want to do common operations, like say, if I've logged in, hey, turn on chat and turn on the ability to join a game, right? We don't want unauthenticated users to do that. We can do that within this place. So if down the line I'm like, you know what, Google and email and password, that's not enough. I want to add Twitter. I can just go and add Twitter, and then I don't have to change any of my logic anywhere. My listener still fires, which is really nice. So here I have two windows next to each other. One of them's a private one of them's another one. I've got something covering my URL because I haven't implemented any security rules on this, so I don't want you seeing where it is that I'm doing stuff. Don't do that in production, that's bad. So what I want to do is create myself a user. I'm actually just going to refresh this and make sure I have my wireless connection is still working. I'm going to create an account. I'm going to call it David because it's my father's name. And I'll create an email at my domain so no one gets spam. And I'm going to create a secure password of password. And I'm going to create that user. And now that user is actually logged in. One of the default things of when you create a user, it by default logs you in, which makes things a little simpler. And now that user is logged in. The next thing I want to do is show how the chat system works, right? Any good multiplayer game needs a chat system, because otherwise how would you send really mean things to people you're playing? It looks pretty much like this. It's nothing particularly complicated. There's a display name and some text. Sweet, and a little send button. But chat needs to be real time, right? We want chat to be relatively real time. We need to send messages backwards and forwards. And this is one of the places where in Firebase really kind of excels as well. So Firebase has this really cool thing called the Firebase Realtime Database. This was like one of the core things that Firebase started with and still continues, I think, to this day to be one of its major and core products that I absolutely adore. So the Firebase Realtime Database is, you think of it as basically data storage where everything's like just one big JSON blob. Like it's a NoSQL data store, but it's just one big JSON blob. That's pretty much what it is. But what makes it really, really, really powerful is that I'm able to turn around to it and say, hey, this particular part in this tree, in this JSON data structure, I want you to watch that part. And if that part changes in a variety of different ways that you can control, I want you to let me know. Maybe with a callback, maybe with a promise. But I don't want to have to worry about WebSockets or long polling or talking to a server or anything like that. I just want you to let me know through the SDK. And you just take care of those hard problems for me. And so Firebase does that for you, which is super cool. So building chat within Firebase is just ridiculously easy. First thing we do inside Firebase, we've already done our configuration, but we say Firebase database, give me a ref. What that means is like, give me a database reference to a particular point in this JSON tree. Here we're going to say just /chat, because that's where we want to put all our chat messages. I'm then able to say, hey, push in a value into that particular place, that ref that we have. Here we're pushing in just an object with a name and a message. But what's neat is we get this map it's a map of objects in there, but a unique key is created for us when we do this push value. The nice things about these keys is actually they're automatically ordered chronologically, so you don't have to resort anything by like timestamp. It's really, really handy. But now, once I say push, I have /chat, a unique key, and then these values that sit behind it. And those get pushed straight into the real-time database. So that's pushing data into our chat application. But obviously, we want to be able to react to when that data comes in, regardless of whether I'm the person pushing it in or whether I'm just sitting there waiting to see messages to occur. That's also really straightforward. So we have the ref from what we had before, but we can just do an on handler. And one of the change events we can look for is child added. And from there, I have a callback. Again, you could use promises. The SDK supports them. I use promises because it's just simple to show. Whenever something gets added to that list of chat, I get my callback called with a snapshot of the data, and then I can do some DOM manipulation through add chat message and display it on screen. And that's my chat app. Like, that's it. That's all I've had to do. So here I have David. He's logged in. I can write a test message. Hello. What are we? JavaScript Israel. I hit send, and it shows up in both places. I should respond, because it would be rude otherwise. Hello. And I can respond back. If you want to actually have a look at the Firebase Console, which is neat in and of itself, we can actually see that data structure that's built right here. So here were the previous chat messages, but here are the ones that we had before. Here's that unique key we were talking about for each message, and then the values that are there as well. It's also worth noting, right? So here we have my real-time database stuff, talking about authentication from before. Here I have my own little admin interface as well for all the users that are in my system. This is something else I didn't have to build, which is really, really nice. Right? All this stuff came right out of the box. I didn't actually have to build any servers or worry about any of that sort of fun stuff. So the question is, how do I set, now just so I can clarify. So when I first create the project, so when I first create my JavaScript code, how do I set the project that it's accessing? Right. So on the initial slides, you saw I did a config there. That config sets it. So in that config that I copy paste, which I can actually show you right here. So if I go web setup here, it gives me the code right there that I can literally drop in, copy paste. And that tells it what project it is that I'm talking to. We have authentication, excellent. We have chat, so we've got some real-time messaging. Let's get more complicated with this. So we have matchmaking. So if you're not familiar with the term matchmaking, what that means is I want a player to be able to say, hey, I'd like to start a game. And I want another player to be able to see that somebody has said, hey, I'd like to start a game, and be able to join them in that game. And that's the UI I have. I can click create a game. It'll list the games that are available to everyone. And then I can click that button and continue on my merry way. And we can play this very silly game that I'm talking about today. So the question was, what happens when it gets too big? It's not a problem. You get children events. So for example, Twitch uses Firebase for chat, and Twitch is huge. So it's not an issue. So when you're doing, the interesting point to make here around like with chat and stuff like that, you subscribe to the child added. So whenever the event comes through, you only get the child.
Not the whole.
You don't get the whole tree. And when you first join, right, I haven't actually set defaults for what I would get when I first joined up, but you can do that. You can be like, give me the first 50 messages or the first 20, stuff like that. Sorry, the question was, would they come in the wrong order? And I don't think I've ever seen that happen or heard that ever be a problem. Bringing two people together so they can play this game of happy, surprised, angry. I want to be able to create a game, and I want to be able to join a game. To give you a little bit of idea of the data that I'm sort of putting into the database, this is what basically my game looks like. It's a JSON blob. It has a state, right? So I'm going to have an open state for games that people can join, a closed state, a joined state for once somebody has joined the game. And we'll have some more states as we kind of go down the line and play this game. We're going to set it with a creator, so like who created this game initially. They have a display name and then a unique identifier for their account. The joiner is the person who then joins that game. As we were talking about before, they have a state of either open or joined. So to create a game, pretty much exactly like what we did before. Instead of having /chat, we do /games. We grab the current user as the person who's going to create this game. We set up a data structure, which we outlined pretty much right like we did before, and we push it into our system. Now we have a list of games. We do, however, have a small problem, which is what happens if two people try and join a game at the same time? That would be bad. One player is like, I joined, I think I'm playing. The other player is like, maybe I did, I didn't, who knows? That's not ideal. So we really don't want this to happen, right? This would be very, very bad. So the nice thing is Firebase gives us some nice things to make sure that this is an atomic operation, right? So only one person can join at a given point in time, or someone can only do an operation at a given point in time, which is really cool. And that way, it sort of obliviates this problem. If somebody joins and it's atomic, this person first joins, and then the second person comes in and goes, oh wait, this game's already in progress. Well, oops, I'm too late. I'll try again on a different game. How does it do that? It has this wonderful thing called transactions. Here we create a ref, much like we did before, but on this one, I'm actually going to pass in that unique identifier that I already have for a game when I did my push. That means I'm just interacting with this one single game that's currently going on. I can then from that ref say, hey, transaction, and basically that means that callback, that single block of code that runs in that transaction, as long as that block of code and that callback is running, like that's the only one that can access that particular unique key that is under that ref. So here I'm just going in and I'm like, OK, if I don't have someone who's already joined this game, set the state to joined and make me the joiner, and then move the state on to the next value. Right? Otherwise, we're just going to ignore it. Now, we could do like more interesting stuff. Actually, in my code, which is open source, and you can see it, I pop up a little message saying, hey, like, sorry, this game's already been joined. And we could do more complicated stuff there. But the basic gist of it's there. Go for it. So the question was, can you make this limitation in the database layer? There's a couple of interesting tricks that I'm not going to go into too deeply here. There's things like security rules, and then you can also write server-side code that could interact with the Firebase as well. And that's how you can like check on people cheating and do all that sort of fun stuff. So you'd write it through your client-side code, and then you could fix it otherwise, and then do like bans and other fun stuff. The question was the key being displayed to everyone? I'll touch on that in a sec. It actually gets displayed on screen. It's pretty straightforward, but I'll show you that in a minute. So to actually display, to go to your question, so to display all the games that are available to be joined on the screen, we can do pretty much the same thing as what we did on chat. But the interesting thing that we're doing here is that we're actually saying, hey, we only want those games that are open. Right? We don't want a game in progress to show up in our matchmaking list. That would be bad. But once we do that, we can say, hey, look, ref, everything under games, order by child of state, so what state is it in? And then we can say, hey, just give me everything that's open. And that's cool. That actually just gives me back a ref that's just to those filtered items, which is sweet. I can do a child added. And basically, every time one comes in, I can grab the details and throw it up on screen. I can even do some more cute stuff here, which I do, which basically says, if this is my game, like I created it, please don't show it, because I don't want to join my own game. That would be weird. So I can do that very much the same as I would on chat. If the game gets joined, it actually gets removed, which is kind of cool. It's not that I've deleted the game, but it's that it's actually no longer in that filtered list. So it's actually considered, yeah, it's been removed. It's no longer in an open state. It's now moved to joined. We can get rid of it. And once that happens, then we can do some DOM manipulation and drop it off screen, and everything's hunky-dory. I think that's the first time I've ever said hunky-dory in a presentation. I'm not going to show matchmaking yet, because then we'd actually start a game, but we'll do that at the end. So I'll just talk you through some other finer points of what we have going on inside gameplay, so you can see some other fun things. So this is basically the flow of the states that happen inside this game. We go from open to join, so someone has joined the game. We go to taking a picture, which is cool. Someone can take a picture through the webcam. We upload the picture, and I'll talk through about that as well. Once the file has been uploaded, we send that off to the Cloud Vision API to get face detected. And once we have the face detection, we know what emotion people have, we can put some simple rules in place to say who wins, and then we're complete. In code, it looks pretty much like this. So we're doing the same thing again, where we say, hey, I'm going to look at the reference to this particular game, like this specific game. But rather than looking at like child added values or anything like that, I just say on value. So that means anytime like anything about this particular game changes, let me know. So I can kind of basically do like a kind of state machine, really, quite simply. So whenever that game state changes, I can take actions. So when the state goes to joined, I'm going to fire the joined game thing, which moves me on to being able to take a picture. Taking a picture, I fire up a countdown. So the picture like gets taken from the webcam. Once the webcam's been done, I move over to uploaded. And uploaded will display it and then make sure the event goes over to Cloud Vision API. And so on and so forth until I get to complete. It's a pretty readable code. I munged it up a bit so it can fit on the slide. But like, it should look relatively straightforward to continue on down the page just using a regular old switch statement. If you've written sort of messaging systems or any backend systems that way, I know we're all JavaScript developers. I'm sure some of you do Node. Probably looks reasonably familiar. Yeah, so on value, as anything under game changes, this gets fired. So if the state hasn't changed, I could put checks in there to say like if it hasn't changed, do nothing, which I do in certain places. Or if it's the same as it was before, that's fine, so on and so forth. For this particular very simple game, works fine. Because normally I'm doing a state change plus adding some attributes all together and then sending that off as one big thing. And it works out really simple. If you're doing more complicated stuff, you could put checks and balances in place. I'll look at some of the more interesting parts of this game. I don't want to go through every individual step because there's just no point. So here I'm actually like showing the JavaScript for grabbing a PNG out of a canvas because it's interesting. But really just down here, once I have like a canvas populated with a video stream, I can get a PNG out of it with this function blob. What I want to be able to do, actually let me skip back for a sec, is take that blob of that PNG and I need to get that in the cloud somewhere, right? I need to get that online. If you've used Firebase previously, that's normally the point where you're like, oh man, now I actually have to write a server. I don't want to do that. The cool thing is now, though, is that with Firebase 2.0, you don't have to do that anymore. We have this wonderful thing called Firebase Storage. Firebase Storage is this really neat thing that has been Firebase-ified up, what is essentially Google Cloud Platform storage. So basically a really nice place to put binary files where we give you edge caching and like multi-region redundancy and all sorts of other fun storage type buzzwords. But you can access it really easily within Firebase. I've done a bunch of stuff with Google Cloud Storage, and this is by far the simplest API I've ever used to access and use it. It's really, really sweet. What does that code look like? If you believe that we get a ref, you would be believing correct. In this case, we get a storage ref. We tell it where in our storage we want it to go. Here I'm setting it to game/the unique key so that it has a nice unique space, plus the key of the user, and then just PNG. And I say, hey, if you could like upload that to the internet, put that in the cloud, that would be great. Thank you so much. And then I have an onListener for that upload event. There's a variety of different callbacks we have here for whenever like I'm uploading stuff to files. I can do intermittent bits like, hey, how much has been uploaded, stuff like that. But for today, all I really care about is saying, like, once you're finally done and uploaded this file, run this callback. I pull out some of the Google Cloud Storage stuff in there, but don't worry about that too much. I just need that for Cloud Vision. But really the important bit is where I just say upload task.snapshot.download URL, right? That's the public bit. So by default, this stuff is public read. Because if you're uploading stuff through Firebase, it's generally assumed that you want it to be open and stuff. If you want to be like more specific about it, you have, depending on your plan, you have full access to the Google Cloud Storage stuff. So if you were worrying about permissions, which was the question, you have like direct access to that, so you can set ACLs on it and like access control lists and have full control. So this is where you get back into like security rules and where you can actually access how Firebase works using like server-side code and stuff like that to do like authentication, make sure everything's okay, that sort of stuff. Generally speaking, the stuff going up into Firebase, like if you want to upload stuff, it'd be hard to really kind of DDoS it in some ways, just because Google Cloud Storage is really big and you could go in and just delete it. But there's extra stuff that I'm not talking about today that is a whole bunch of things around security and making sure people don't abuse you, because yes, your keys are public and you can write client-side code. So once I've got that uploaded, great, I can actually go to add that image data to my game. Here, if people have used Firebase before, this is really neat. You can actually do partial paths. I just say, hey, update these values. Change my state here, which we were talking about before in my data. Just want to change that. And just update these particular values within my game. I don't have to do the whole blob. I can actually do just individual parts of it as well. This is what the blob ends up looking like, which is great. You can see we now have a download URL, which we can use, as well as like where the Google Cloud Storage data is as well. Finally, once we go through all our steps as well, like one player wins, one player loses, we set those values in as well once we have that data from Cloud Vision API, and everything kind of goes through. I've jumped through some steps in that state, but I'm not going to go through every individual step. But this is just updating data within Firebase. Again, fires off that handler, and everything goes through that switch statement, and games continue on. OK, let's get to the fun bit, which is actually showing this thing off. What I need now is a volunteer from the audience who wants to play this game with me. So please come up here. No. I'm set up. I am set up here. So come stand next to me. I have it on my phone. I will create an account for you because it makes my life easy. How do you spell your name?
R-O-Y.
It also means there's less things that can go wrong with my demo. I type stuff.
Can you also make a face for me?
No, that you will definitely do yourself. Okay, so you're set up. What I'll do is get you to stand here. I will move over a little bit. I'm going to bring this up actually on my phone. So what I'm going to do is I'm going to create a game, and it'll show up in that middle section we have there. We can actually make that a little bit bigger because I don't have two windows anymore. So why don't I do that? Don't click it just yet. Cool, so I've created a game. Wonderful. It's shown up there on our list of matchmaking. Now, once you click that button, you'll get a countdown that'll go down to 3. Now, you need to make a face once it goes down to 3, possibly a little before, of either happy, angry, or surprised. Sounds good?
Yeah.
I'm going to do the same on my phone, and we'll see who wins. Sounds good? Are you ready?
Yeah.
Click the button when you're ready. Excellent. I got a notification that Roy has joined the game. Actually, I'll go that way. All right, mine's uploading. Looks like yours is uploading. Wonderful. Oh, it gets unknown. Oh, that's boring. Let's not do that. All right.
It's the beer.
We got 3 minutes left. It's good. Let's play again. Excellent. All right. Well, I'll tell you what. This time you create a game. So you click create a game. Excellent. I see you there. So I'm going to click join Roy. You get a little notification. Excellent.
Don't cheat.
All right. So you got surprised. You got surprised.
He doesn't like me.
Oh, that's normally angry. I think they might have been updated this. Anyway, you won. Thank you very much for joining me on stage. I really appreciate it. I think they must have changed that. Normally that face really gets an angry. So, finally. So what did we do, right? We built ourselves a game, but we didn't really ever worry about like servers or scale or like how much data or storage or really any of those sort of really annoying ops types things, right? But we were able to sit down, build a nice JavaScript web app that interacted with other players in a game, did matchmaking, did real-time chat, did some pretty powerful stuff without having to worry about any of that stuff and just writing client-side code. So I say to you, the next time you sit down to make a game, or possibly an application with similar type things, you might want to consider Firebase. It's pretty powerful. It's got some really neat pricing plans that make it really easy to get into. And I think you might find it fun and interesting to kind of play around with. Before I go to questions, I will just quickly throw up some stuff. If you're interested in this, firebase.google.com, first place to go. If you want any of the code that I showed today, it is available at that GitHub address right there. I would be remiss if I didn't mention the fact that I am one half of the Google Cloud Platform podcast. We've had several episodes about Firebase, including the stuff that was on at I/O. So if you want to listen to that stuff and learn more about the things that got announced and the features that Firebase has, it's a really great resource. And there's also a huge number of Firebase talks available on YouTube as well. So the question was, do you go back and delete the data? That's an excellent question. I got 1 minute to answer. Perfect. So the way I look at data within Firebase is very much, it's kind of ephemeral, right? You're really just putting the data inside the database of whatever the current state of your system is. Now, if you have games in there from before, do you delete them? You could. You don't have to. It's not the end of the world. Yeah, that's okay. Like the pay-as-you-go system, like you're paying for storage. I'm trying to remember if you pay for storage within Firebase Real-Time Data. Have a look at the pricing page. I can't remember off the top of my head. Generally, the pricing is more about how many concurrent connections you have than anything else. But the pricing is like dead simple, so you can go have a look. There are more questions. I'm out of time, but I will be here all evening. So please feel free to grab me and we can have a chat outside after the next talk. Thank you very much.